we are looking at the back side of your notes, lesson 3.5, day 2. I'm on example B. I entered my data. I turned my plots on. I'm looking at list 1 and list 2. I hit zoom stat. I look at the data. It looks as though it might be exponential. We're going to go and check all 3 equations, the log, the exponential, and the power. If you look at the front side of your notes, if we think it's a log equation, just look in here. If we think it's a log equation, that means we've got the natural log of x times y. Again, looking at the front of your notes, if we think it's a log, if you come over here, it tells us what to do. We're taking the natural log of the x's and we're leaving the y's alone. So I'm going to write that down. Natural log of x, y stay the same. If we look at the exponential, that's the one that we had done in class. That's where we're leaving the x's alone. We're taking the natural log of y. And then finally, if you look at the power regression, we're taking the natural log of both x and y. We're going to start over here in that first case. See if I can get the glare out of the way. There we go. I'm going to go over to list 3 again. I'm taking the natural log of the x's, which are in list 1. So natural log of list 1. And now I want to go find a linear regression based on these new x's, and here's my original y's. Stat calc, going to linear regression. Our x list is actually in list 3. Our y list is in the same location. And we're going to write down that equation. Y equals 18.44x minus 3.889, and I'm going to include one more decimal in here. Now remember, one of the reasons why we're linearizing the data is so that we can figure out which equation is best. One thing I'm noticing is I don't have my R value, which is my correlation coefficient on. I'm going to go into that catalog. If you recall, that's the diagnostic, so I'm going to hit alpha D. Diagnostic on. So I'm going to go run that test again. Go over to calc, linear regression, list 3, list 2. I go in and calculate the R value. I get 0.89255. So not a very good correlation coefficient. Let's go check the exponential. If you take a look at this list, we want to leave our x's alone, and we're going to take the natural log of the y's. So going back into my calculator, I'm going to go to stat. Again, here are my x's, here are my y's. I'm now going to take the natural log of my y's. I can clear that out. Take the natural log of your y's, which are in list 2. Now we want to come up with a linear regression based on these x's with these corresponding y's. Going back to stat. Calc, linear regression. I'm now back to list 1, where my original x's are, and list 3, which is where my new y's are. Writing down that equation, and technically this is not y equals, this is natural log y equals 0.577x plus 0.369. My R value is 0.9854. Definitely better than this one, but let's go check the power one. Now, one thing we also want to do is this is supposed to be an exponential function, so we're going to change it. We did this in class yesterday as well. When it's a natural log, it's understood to be base e, so I'm going to rewrite this as y equals e to the 0.577x plus 3.69. We're breaking these pieces down. I'm going to type in e to the 0.577. And I'm going to type in e to the 3.69. Plugging those into my calculator. end up with e to the 3.69 is 1.446. E to the 0.577 is 1.781. Okay, I just wanted to give you a visual. There's the data that we came up with. There's that exponential equation that we can see. Last case, we're going to go and see if it's a power function. Notice in this case, we're taking the natural log of both the x and y values. I go back into my statistics. I'm taking the natural log of my x values, which are in list 1. I'm taking the natural log of my y values, which are in list 2. And now I want to come up with a linear regression based on both of these new x's and y's. Going back into stat to calc, linear regression. In this case I'm looking at list 3 and list 4. Let's write down that equation. And remember, it's not y equals, it is natural log of y equals 1.647x plus 0.583. Notice your r value is 0.996. So actually, it's not best to be an exponential regression. It ends up being the power regression. One thing I goofed on here. In this case, this is not x. Remember, we took the natural log of x, and that was plus 0.583. Now, if you look at the function for a power function, it's y equals cx to the a. That means I should be able to transform that equation into that power function. So we're going to do that next. Similar to what we did over here, this is understood to be a base of e. We have y equals e to the 1.647 natural log of x plus 0.583. We're going to break this down into pieces. I'm going to rewrite this as y equals. I'm going to do e to the natural log of x raised to the 1.647. So I'm allowed to flip that order because multiplication is commutative. This would be times e to the 0.583. This was actually one of your questions on your most recent quiz. It's also a property of logs. E to the natural log of e to the x, this base and this base are the same. I actually end up with x to the 1.647. When I plug in e to the 0.583 power, I get 1.71. So finishing it up, so it looks like it's in that form, 1.791, 1.647. I forgot the base in this case is x. Excuse the doggies chewing on her book. I'm going to pause it and show you how this one looks on that graph as well. Alright, I just wanted to give you a visual. Again, there's the data. Look at the power function. It looks a little bit better than the exponential. Mathematically, we can see it's better from the correlation coefficient as well. C would just be another example. I'm not going to take the time to do that. I'm trying to keep your video pretty close to 15 minutes. Let's go on to D. This is really just manipulating equations and writing them in the corresponding form. Let's start with 3 and 4. These are the ones that we really have been working on. We've got a natural log and we have a log. We want to flip it to exponential. This one is understood to be a base of e. This would be y equals e to the 2x minus 5. That's e to the second raised to the x power times e to the negative 5. Again, we're going to plug these in our calculator. E to the negative 5 is 0.0067. E to the second is 7.389 to the x power. Let's go look at number 4. Notice this one is actually a base 10. Same steps as we did here, only instead of being a base e, we have a base 10. This equation becomes y equals 10 to the 3x plus 6. We're going to rewrite this as 10 to the third raised to the x times 10 to the 6. Again, plugging in my calculator, 10 to the 6. 10 to the third. And I flipped it to an exponential equation. Back up to number 1, the directions should say they're in exponential. We want to write them in linear form. We want to linearize using the natural log. I'm going to take the natural log of both sides, and I'm going to try and rewrite it in the format y equals mx plus b. There's my natural log of y. Remember, when we're multiplying, we can separate that out as the sum of the two logs. I've got that x. I'm going to bring that x out in front. Natural log of 1.7, I can find that on my calculator. Natural log of 1.7. And I'm going to put that at the tail end just so I'm getting it in that format. That would be 1.7 is 0.531. If I go type in the natural log of 5.6, which ends up being my slope, I get 1.723. Now it's in a linear form. Let's go look at the second one. Same deal over here. I want to linearize using the log. I'm going to go take the log of both sides. Similar to what we did over to the left. We're going to separate this out to the log of 2.58 plus the log of 0.97. You've got that power of x. Let me switch that over. I'm going to bring that x to the front. Log of 0.97. I'm going to type that in my calculator. I get negative 0.0132x. If I type in log of 2.58, I get 0.44, and now I've got a linear equation. So tonight you are doing lesson 3.5, day 2, has some of this linearization really on a little bit more basic level, and it also has some review on solving log equations. The second part, and that part's due by midnight tomorrow night. The second part, you've got the review worksheet. You either picked it up, or you can print it off, or you can put it on separate paper. I would at least get started on the first 12 to 15 questions. That will leave us some time in class on Thursday to work on it as well. If you have any questions, you need anything in the video